Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Galen Hunt is a principal researcher and research manager at MSR Redmond, where he leads the operating systems group. Galen joined Microsoft Research in 1997. He had previously been an intern. He received his PhD in computer science from the University of Rochester. You may have noticed a theme here, lots of Carnegie Mellon, but also lots of Rochester here today. Galen is going to actually be giving us a talk about some OS research. I thought we had to fit that into the day somewhere. Yes. So, thank you, Galen.
Yes, we have. Would somebody go get Satya? He needs to hear my talk. All right. So my introduction to Microsoft. So I was an intern. In 1995, I had been a first-year graduate student at the University of Rochester, and my advisor said, "Hey, I've got a former student, Bill Belosky, who's at this place called Microsoft Research. Why don't you apply there to go do an internship?" And I didn't want to go to Microsoft Research. I had made a progression in personal thought about Microsoft. So before that, as an undergraduate in my earlier life, I was a Steve Jobs fanboy. And my philosophy of Microsoft was pure evil. I was absolutely convinced of this. And somewhere around the time I went to graduate school, I learned that you shouldn't always assume evilness, okay? And so I had evolved to where I just decided that Microsoft was not evil, it was just grossly incompetent, okay? And so I got this offer from Bill Belosky to do an internship, and I held on to it for 2 months, because I had also applied to Park and Bell Labs, and that's where I really wanted to go. And after 2 months, I decided they weren't going to make me an offer, so I'd go ahead and do the internship at Microsoft Research. And Bill started me off on a project, and on about the third day that I was at MSR, we had lunch with Rick, because he was then the manager of the systems group as well. And after lunch, Rick stopped by my office and said, "So what's Bill got you working on?" And I told him. He said, "That's a stupid idea. You should do this other thing that we should try to do it instead." And the other thing that he thought we should try to do, kind of related, it was the time when they were doing Tiger, and that was, rather than using fiber, which is basically what Tiger was going to be using to homes, could we do something over the internet? Could we do video over the internet? And so I did a project, and the theme of this session is Rick is the Renaissance man, and a Renaissance man is someone who can do anything, right? Well, Rick was my tester. So I would write code during the day and mock of trying to do streaming audio and video over the internet, over IP. But I didn't have a computer at home. I couldn't do anything streaming. And so Rick every night would take home, I don't know how he probably on a floppy at the time, the latest bits that I had come up with, and he would run my test from his house, trying to stream from MSR to his house. And then he would come back in the morning and he'd tell me what didn't work. And then I'd code all day furiously, and then he'd try it again. And after 3 weeks, I had the prototype working. And I don't know how many times Rick had to watch If You Give a Moose a Muffin, but many people did, actually. Okay. When I came back, evidently the internship worked well enough that Rick tried to convince me that I should keep an ongoing relationship with MSR. And so I came back about 3 months after my internship. And here's one of my wise things I learned from Rick. And I'd found out that I'd done this great prototype, but the developers that were actually working on the project had thrown every single line of my code away. Everything. They'd thrown everything away. And I was complaining to Rick about how terrible this was, that they'd thrown all my stuff away. And he said, "Well, actually you win. Because when they rewrite your code, that means that you actually convince them. And so as a researcher, that's all you have to do." There's a correlation, and I don't know if he said this or not, but I tell it to my people all the time. It also means you're not responsible for the bugs, because they put the bugs in, not you. And my other corollary from that is that you really, as a researcher, you shouldn't write any more code than you have to prove an idea. Okay? And I'm going to do the extreme, as I talk about a piece of research that we've done recently, I'm going to do the extreme example of that. And that is reusing roughly 5.5 million lines of Windows with a few tens of thousands of lines of our code and be able to do something that's never been done before. And so this is where we tie nicely in with Satya's talk from earlier in the day about virtual machines. Okay, so virtual machines basically got this great thing that you can take an application stack, so an app and the Windows subsystem and the NT kernel, and you run it on hardware. But if you insert a virtual machine monitor and another copy of the operating system, you can get many wonderful properties that Satya described. I generally summarize them as you can get secure isolation, you can get persistent compatibility, which is the ability of you can change the host and the app still keeps working, and you also get some other property that I can't remember at the moment. Anyway, so persistent, I really can't remember at the moment. Okay, but the problem is this wonderfulness comes at a very, very high price. There's lots of fat. And basically the source of the fat is you've got this, it's all revolves around this abstraction of a complete copy of a PC. And so the virtual machine monitor has this whole layer that emulates hardware, and then right after that, right on top of that, you shove an operating system and a bunch of drivers that go back to abstracting that hardware away. Okay? And so our insight was, well, gee, could we, if we want to do the most radical thing you could do to a virtual machine, could you actually remove all the hardware? And what would that look like? Well, it turns out this isn't a radical idea at all. Okay? In fact, basically the inspiration for this was the 1990 paper about Unix as an application program. Okay? And this is where it ties back in with Rick's work. And basically the idea here was that, you know, Unix, there's a bunch of services, the personality operating system, the services that the applications need have very little to do with what's actually going on in the hardware abstraction portion of the kernel. And so you can actually separate the personality out. And in the original paper, there was a small library that sat inside the process, and then Unix actually ran as a service on the side. Okay? And our twist on this was, gee, what if we actually put Unix or the operating, so the OS personality inside the process? And why would we want to put it inside the process? Well, the reason we want to put it inside the process is that some colleagues of ours at MSR came up with this idea of what's called a pico process. And they said if you take a process, a traditional operating system process, and you remove all access to operating system services, what you end up with is this pure isolation container. It's a virtual address space, and you can run code inside it, but the code can't get out of it. Well, the problem is you actually need the code to get out a little bit. And so you can create an interface, but the interface, rather than looking like this Baroque PC circa 1995 from my internship PC, you could actually create a little bit higher level of abstraction. Well, but then the problem is you've got this great container. You can provide us some basic services like, say, virtual memory and communication, but how do you run rich Windows applications inside of it? And that's really the problem, because these Windows applications actually expect a very, very rich set of services from the host from their operating system. And so the core idea is going back to looking at a contemporary idea from the Library OS from Dawson Engler's work of, well, you can actually take the operating system personality and run it right inside the process with the application, because you don't care about what the security context is. Okay, and so this code that used to be OS code doesn't have to be protected from the application anymore, because that container, the Pico process, is the isolation container. Okay, and so we created a subset of Windows, a Library OS, and in the examples I'm showing, it's about 100 megabytes on disk. But the beautiful thing of it is it's only about 16 megabytes of working set, which is huge by old-time standards, but really, really small by modern-day standards. Okay. And what makes this all possible is this ABI, the binary interface between the application, or between the Library OS and the host system. And the key thing is it's a higher level set of abstractions than hardware. It's threads, virtual memory, and I/O streams, but still maintaining the core qualities that you see in a virtual machine monitor, which is that the interface should be closed, it should have a fixed semantics, and it should be stateless. Okay, and as a result, so I'll demonstrate. One of the things I've been doing since my internship is I've always believed in actually demonstrating the system. That's the only way to really kind of get all the ideas across. Oops. All right. So the first little demo we're going to run. So this is Excel running Excel 2010 running inside a drawbridge Pico process with a library OS. Okay, and it's really Excel, and the way I always prove that is I can actually create a pie chart. Okay, so clearly it must all work if the pie charts work, right? Okay. Okay. But this Excel, because it's running inside a Pico process, we can actually encapsulate all of the state of the application in the library OS with basically the dirty pages inside the process. Okay, and so I can do a per process hibernation or process migration. Now, and it works real easy because all the state is actually there in the library OS with the application. And so what we end up with is if we write the dirty pages out to disk, it's about 30 megabytes. If you add the open files and zip it together, it's about 3.5 megabytes. So it's about on size of the order of an MP3. Now, I contrast this with a full hardware-based virtual machine where you have a full copy of the operating system. For there, if you want to migrate, the thing you have to migrate is on the size of a DVD. Okay, and so it's a huge, drastic difference. And to show you how fast we can actually resume it, so let's see. Okay, so I can actually bring it back up, and here's my app, and it really is still running. And the key thing is I didn't suspend and resume. I didn't save the document out to disk. I actually saved Excel out to disk. Okay. And one of the other problems so we've drastically reduced the overheads not only of storage, but also the execution environment from a VM as well. And so I have a laptop here. It's got 8 gigabytes RAM. And on a tradition, if I was using a virtual PC, I could start 2 or 3 virtual machines with a hypervisor-based solution on this machine. Okay. Well, I'm going to just, oops, wrong demo. Okay, so I'm going to start 7 different apps, all in their own isolated Pico process. Okay, and they started up in about 2 or 3 seconds. They're each completely isolated from every other application on the system. So I can suspend, I can resume, I can migrate them to other machines, etc. And then the last demo, to give an idea of how high a density of virtual machine we can put per physical server, I'm going to start some web servers on my computer. And each one of them is running inside its own Pico process, its own virtual machine. It's got its own private copy of the library OS. Let's see, let me shrink this down. Okay. And I can start 200 of them in about 25 seconds. Okay? If I was starting virtual machines, I'd only be able to get 1. And they're all running, and I can actually run full 200 of them on this machine. Okay. So, so what we end up with is this very, very narrow waist, as Satya alluded to, of the virtual machine, that allows us to separate the evolution of the application personality, the OS personality, which is basically the Windows subsystem, for example, that's experienced by applications from the core, the kernel. And that allows us to do rapid evolution of them independently. So we get all the benefits if I can run, say, a Windows 7 library OS on top of a Windows 8 machine or a Windows 7 machine. Okay? And in fact, we've done this. We've to prove that the waist is as narrow as we believe it is. We've actually done a number of different library OS implementations, and we've run them across a slew of hosts ranging from current Windows to the Barrelfish research operating system that was done between Cambridge and ETH, and also some other strains. So some things that look very much like Windows as a host and some things that look very unlike Windows as a host. All right. So now I want to go back to my internship. So at the end of my internship, I went home. I remember going home to my wife. To my wife. We were newlyweds that year. And I said, you know, I'm still not sure about Microsoft, but Microsoft is the dream jobs I always wanted but didn't know existed. And I count myself extremely fortunate to be able to work at Microsoft Research. It was a chain of lucky circumstances that brought me into being Rick's intern for that summer. And it has been one of the greatest gifts that I've had in life. Thank you, Rick.
Thank you, Galen. So next we're going to have Andrew Herbert. And it looks like you're not projecting.
Nope.
Okay, so Andrew retired from Microsoft actually last year. I believe the last job he had was chairman of Microsoft Research for Europe, the Middle East, and Africa. He joined MSR in 2001 and became managing director of MSR Cambridge in 2003. Andrew.
Thank you, Rick. Are we in business now? Yes, we are. Excellent. So, one of the reasons for retiring was not to be dragged across to Redmond every March for 2 weeks. Well, retiring, it's now minimized to 2 days, so there must be some other transition I can make that means I won't have to do this. Although I do have to kind of renew my American float plane license every 2 years, so I've got to be careful now. I'm close to a boundary condition where it might not quite work out exactly right. I was struggling to think about what the jokes should be. I'm actually surprised about how few Star Trek references there have been. So I was going to be a bit lame and say something about alien technology. Abandon that one. I really was not expecting it to be open season on Jennifer Chase. One of my pleasures as a lab director is every now and then, if you're lucky, Rick selects you for one of Microsoft's executive training programs. And on one of those, both Jennifer and I attended, and we got put in the same group. And it was the time when executive training was a kind of group therapy thing. And if you can just imagine me as a slightly uptight, stiff upper-lipped Brit at one end of the table with Jennifer, who is not British and stiff upper-lipped and so forth, the other. We had a fascinating time. I now understand what full-scale deflection means. That's what Jennifer does. That was great fun. And actually, we became very good friends through that process. So that was great fun. And I have one other complaint, and the pub's been open now for 6 hours. There's not a beer available in the place. So, Rich, we were going to put a picture up. Can you still do that while I prattle on? Thank you. So I've picked the topic Rick Rashid, aeroplane pilot. Trying to think about some things I could say about Rick a bit different to other people. One of the pleasures of being an overseas lab director is you basically get Rick for a week every year, and you have to kind of do something useful with him, and it's probably good for your career if he goes back home feeling he has done something useful. And so what we would do in Cambridge very often is invite Rick to come to our tab and then do some things, academic partners. He could spend some time in the laboratory and meet people and so forth. And that went really rather well. And so one of the things I used to try and do when I ran the Cambridge lab is arrange for our tab dinner to end up at some interesting venue so that we could kind of get away from the lab and see some interesting things. And I organised 2 trips, which I know Rick enjoyed. In 2008, we went to Bletchley Park, the place where the British broke the German wartime codes, and we showed everyone who attended, including Rick, a replica of a machine called Colossus, which was arguably one of the first computing devices, and that broke the German Tunny code. There's a very interesting TV program about that, which hopefully will make it onto the American networks, where they try to explain the relevance of Colossus. Everyone kind of knows the Enigma story, and that's where Turing did his work and built an electromechanical machine called the bomb. Colossus actually was dealing with German telegraph traffic, teleprinter traffic, and this TV show gave a nice analogy as it was if we cracked Hitler's BlackBerry, because it was the communication between him and his major command centers. So that was kind of a great trip. The next year I thought, how do we follow Bletchley? I took us to a place called Duxford near Cambridge, which is a big aviation museum. In fact, there's a place I'd taken Rick and his family previously. Rick, Terry, and the two boys came across to Cambridge. I can now explain to Anadan on the back of that visit why you can't get Terry to come to other places, particularly Bangalore. To get to Bangalore from this part of the world, you have to stop at Heathrow. The Rashid family had a very bad leaving Heathrow experience. I can't recall the precise details, but I think basically they were locked on the airplane on the tarmac for some enormous number of hours. 9 hours. Doing that with two small kids, and I think no food and hot and whatever. I think Terry said she's never going through Heathrow ever again. In August. And it was the hottest August ever or whatever. So basically, Anadan, you have to find an airline that goes to Bangalore from this part of the world, not via Heathrow, then you might manage it. And certainly, I could never get Rick to bring Terry on a UK trip again. It's completely off limits. So we invited Rick to come to Duxford, and Rick has always kind of been interested in various kind of technology and aeroplane things. I thought he would enjoy that. And that was the year I just bought myself on the strength of the nice bonuses that Rick kept giving me. That aeroplane, it's called a Chipmunk. It was the British Air Force training aeroplane immediately after the Second World War. That aeroplane is a year older than me. Since it has annual maintenance, it's actually in somewhat better condition. It knows more about flying than I do, and we have quite a good relationship on the back of that. So I arranged for one of the display pilots at Duxford, this guy here, Clive Denny, to take Rick up for a flight. Clive gave an aerobatic display for the audience. I probably need to waggle something. I probably do that. There we go. And then after that, he took Rick for a flight over the local area to the place where I keep the aircraft a few miles away, and brought him back for dinner. Rick came back with this huge grin on his face. It turns out I hadn't realized that Rick's father had been in the American Air Force, based in the UK, in that part of the world. And so the area he was flying over was where his father had been flown, and that obviously was quite important to him. So unbeknownst to me, those two tab meetings, Bletchley Park and the kind of restoration of old computing devices, and Duxford historic flying, it was actually setting an agenda for me, because since I've retired, I essentially have two projects that are keeping me occupied. One is at Bletchley Park. We're working towards building a replica of EDSAC, Maurice Wilkes' first machine from 1949. So I'm learning a lot about vacuum tube electronics and so forth. And we're making quite good progress with that. We're essentially having to redesign the machine because they didn't keep the blueprints, but there's enough photographic evidence and description and so forth that you can kind of work backwards, as the guys did who built Colossus, and we're kind of picking up some of their expertise. Though it turns out Colossus was built by people who were from the phone company thinking about automated switching. Wilkes had a radar background, and those are two very different cultures. And you discover people refighting electronics wars of the 1940s about which kind of circuits you should use. It's amazing how these fights we have in research about one thing versus another, they just go on for decades and decades. The other project is, I'm doing a lot more these days with more old aeroplanes, including building a very large seaplane with Clive and his company. Rick, I think, also got a little bit of a bug at that point. And here's where I'm going to gently undo all that huffing and puffing about retirement that Rick Draves did at the beginning. It's very dangerous for me to get near aeroplanes because it kind of got me sucked out doing those things. Rick has taken flying lessons in the last 6 months or so. He's been posting progress notes on Facebook, and I think you're at the stage now where you're in what is known as consolidation after the first solo flight. I don't know your experience like. For me, I still remember that first solo. There's that moment where you take off, you're in the aeroplane on your own. You take off and you go, wow, it's me, I'm flying it by myself. And then you think, shit, now I've got to land it. And there's that very nerve-wracking crawl round the pattern, and when you get it back on the ground, you say, oh, thank God for that. Then you just kind of, you're really hooked at that point. After first solo, you then spend a lot of time learning how to navigate cross-country, and I guess the next few trips are about flying to distant airfields and places you've not been to before. And in due course, you get a pilot's license. I do think Rick is learning to fly the wrong kind of aeroplanes, and he's doing it in the wrong place. Flying rather modern machines made out of Tupperware with buttons you push to make them fly. My passion is these things that are made out of wood, bits of bent metal and canvas, and you can kind of got ropes and things moving around inside them. Stick and rudder flying is where it's really at. On the other hand, you don't want to get caught out in one of these in bad weather conditions and so forth. You're flying in Prescott in Montana, and I think the weather there is a lot more blue skies than either Seattle or Cambridge has to offer. Sorry?
You have not flown in our winds.
We can offer you winds in the UK. This thing is quite exciting once the crosswind gets above 15 knots. It's a tail dragger, so the centre of gravity is behind you, and the back wants to be around the front. That has occasionally happened to me. I took my wife on a trip. She's not an aviator, but she's a fairly willing passenger. We landed somewhere and sort of, we had an arrival rather than a landing. Hit the ground with a bit of a bump, and then the aeroplane did 4 revolutions. Fortunately, we ended up pointing in the right direction, so I kind of quietly said nothing and taxied off. Various of my flying buddies who've seen this, when she came out and said, gosh, you're remarkably calm for someone who's ground looped. She said, oh, what's a ground loop? I thought he always landed like that. So my offer to Rick is, when you've got your pilot's license, do come across to Cambridge, and Terry, if you can stomach Heathrow, you're welcome to, and come and do a bit of old-fashioned stick and running flying in a real aeroplane, and the kind where you can leave the roof off so that you get some pleasure. So I wanted to say a few words about the pleasure of having Rick as your manager, as a lab director. It was a great privilege to be invited by Roger Needham to come and join the Microsoft lab in Cambridge in 2003. Rick and Roger had tried to get me a bit earlier on, but I was kind of tied up doing something else. It's not often you get 2 invitations to have such a great job. I think many words have been said about Rick as a manager that I don't kind of need to repeat. His laid-back style is kind of hard to read sometimes. I started playing a game of how little do I have to interact with Rick before he eventually plays chicken and calls me up and says what's going on. I think I managed 1 year to go from review cycle to review cycle with almost 0 management interaction, but I lost my nerve first. Most of my reviews seem to be those kind of... He phrased it slightly subtly. It seems to be going fine in Cambridge. And that word seems bothered me. You could kind of read it one way or the other. But the number score and the pay packet seemed to be going in the right direction. So I kind of was happy with that. So that was great. So certainly he's very supportive. I was able to grow the Cambridge lab from 50 to about 150 people. And he let me do all kinds of crazy things, like adding Stephen Emmett's computational sciences group, taking in Kenwood and the CML group, all of which I think have added to Cambridge's success, although in both cases when we kind of started those, they were a bit of a leap. I recall just a few bits of management advice Rick gave me. One was to make sure if there's bad news, he heard it from me first, and then he'd help me deal with it. I tested that when we ran a port of Windows on the ZenSource operating system. I'm sure Rick will remember that fire drill. That was quite entertaining, dealing with the Windows group getting a little bit upset about that. I think we eventually calmed them down. He may also remember another occasion when he was visiting one of my Italian properties. It was when I was kind of knowing I was thinking about moving on, so I asked Andrew Blake and Fabrizio, who ran external research, to take Rick on the Grand European tour that year. One of our Italian academic collaborators chose that moment to send a letter of protest about something he was a bit upset about and that I thought I had under control that didn't. The Italian member of the party was sending me this incessant stream of emails and texts predicting nuclear holocaust, all kind of terrible things happening. Oh my God, what's Rick going to do about this? Rick was a master at completely calming it down. He took it on the chin. He said, I'm sure we didn't intend these things to happen. Let's do these following things. And by the next morning, the whole thing was nicely dealt with. And he was extremely charming in it. But I think I did get an email that said, you might want to look into this and do something about it, in his usual style. Certainly if things weren't working, Rick got the message through, but never by kind of beating you up or being negative, but you could just kind of detect something needed to be done. So I would really like to acknowledge the vision and leadership that Rick has given MSR as an organization. I certainly enjoyed working for him. Microsoft Research really does have a huge reputation around the world as a leading computer science laboratory. I'd like to thank him for the trust he put in me in running the Cambridge lab and the support he gave me. So happy landings, Rick, and you have an open invitation, both you and Terry, to come and play with some old aeroplanes. Thank you very much.
All right, thank you, Andrew. So Andrew represented one of Rick's interests, and now we have Greg Bear to represent another. Greg is a well-known science fiction author living in the Seattle area. I've got many of his books on my bookshelf at home. And I got this from Wikipedia, so I hope it's accurate. But Greg has received 5 Nebula Awards and 2 Hugo Awards.
We switch this on?
And there should be a little switch.
Yeah. Is that on?
Yeah.
Okay. So I'm actually doing sort of science fiction and a little bit of tech here. Boy, this is a good thing. There's a slider here. Ooh, I'll beam up if I do that. It's been a real privilege and a lot of fun over the years hanging out with Rick and Terry and all the people at Microsoft Research that we've been introduced to. So in celebration, I offer up this piece based in part on some research I did combining Darwin's radio research with City at the End of Time. And I'm sure that both Rick and Terry remember some of these peregrinations. So imagine a library filled with every possible book. Each book is, say, 410 pages long. Each page contains 40 lines, each line 80 characters, chosen from a total alphabet of 25 letters. The library consists of all possible permutations of those letters in each volume. That is, volumes may differ by just 1 letter, 2 letters, by a single word, or by whole passages or pages. Most volumes will differ completely from their fellows. How long would it take to A, build all those shelves, B, fill all those shelves with books, C, dust all those books? Half seriously, writers and philosophers have been thinking about such a library for centuries. Perhaps the most famous example of the configuration described above is found in the Library of Babel, a speculative essay by Jorge Luis Borges. How big would this hypothetical universal library be? On Wikipedia, we are told that Borges' library would consist of a staggering number of volumes, 25 to the 1,312,000, or 1.956 times 10 to the exponent 1,834,097. Now 1 trillion is 10 to the 12th. Such enormous numbers may limit our acceptance of the very idea. It seems ridiculous to imagine so many texts, or in more cybernetic nomenclature, so many strings. Yet we are fascinated by infinities, and there is a great deal of mathematics that deftly describes, ranks, and even operates with infinities, though of course any infinite number goes on forever. Why then should we be daunted by very, very, very large numbers? In fact, science and mathematics are filled with ideas which involve extraordinarily large numbers. In the 18th century, Gottfried Leibniz speculated that if we could only know the exact position of every particle in the universe, we could predict the next state, the universe's immediate future. This idea codified a deep assumption beneath all notions of a rational clockwork universe, or, of course, knowing these particle positions requires not just observing and measuring, but storing that knowledge and then running calculations to determine the next position of each particle and then calculating how they will all interact, a pretty idea that soon gets completely out of hand. So challenged, we might then blush and claim blithely enough that in the future a calculating engine of sufficient capacity and speed might be able to do just that, which takes us out of the realm of philosophy and into science fiction. There are other kinds of universal libraries. One can imagine a picture library of all possible variations of a 1,000 by 1,000 pixel image, each pixel having a range of, say, 25 colors. Strangely, this picture library would have as a subset the universal library of text described above, since it would contain reasonably high-resolution images of every single page in every single book, but not the combinations of those pages you would find bound up as individual volumes in the Library of Babel. And conversely, the universal library of text would contain word and coordinate descriptions of every single 1,000 by 1,000 by 25 color image embedded in many different languages and codes. one quickly realizes that though these libraries are vast, no single volume or picture or collection can be easily dismissed as nonsensical or empty of interest. Seemingly random arrangements of letters or pixels might contain hidden meanings, for example, the coordinates of an image, or hidden references to other resources within the library, such as the perfect card catalog. And buried within readable text might be additional nested codes and clues, which could even give even Martin Gardner's celebrated Dr. Matrix a very long lifetime of curious pleasures. However, there are quite real strings which the Universal Library will not contain. Among these is a complete readout of pi. Some have called this kind of number pseudorandom because it can be generated by algorithms smaller than itself. When Carl Sagan in his novel Contact supposed that pi might contain a hidden message, many mathematicians solemnly tut-tutted. A random number cannot contain a linguistic message, they claimed. Since pi is infinitely long, an interesting question arises. How many universal libraries, coded as numbers, will any sufficiently lengthy string segment of pi contain? Or does the primary algorithmic nature of pi preclude any meaningful messages included therein? Is pi its own and sole message? Our universal library will, of course, contain equations and descriptions sufficient to reconstruct pi and perhaps even proof of its randomness, but be careful, most of those proofs will be false. Thinking about pi leads us to one possible way to begin exploring a universal library. Pi refuses to be zipped or compressed. Noisy pictures on a digital camera take up more memory than less noisy images because they resist compression. Truly random strings all have this property. They cannot be digitally squeezed into smaller versions and reassembled with complete fidelity, as happens when we compress, say, this speech into a zip file on a hard drive. It seems logical then to assume that all the useless or meaningless volumes within a universal library will likewise resist compression. Whole spaces of our library processed by finding these regions which are compressible, and which we can process whole spaces of our library by finding those regions which are compressible and which therefore contain meaningful or interesting strings of symbols, that is, symbols with a linguistic or at least non-random base. Of course, there's just one way to process. That's just one way to process a universal library. Another logical deduction is that half of the volumes or strings in this greater mass will be palindromic. That is, they will mirror reversals of other strings. There will also be other more subtle symmetries which our ambitious librarians can take advantage of to reduce their searches. We could, for example, encode our library as a cubic construct of symbols, each coded in 8 bits of data, arranged 100 or say 1,000 to a side. There would then be rotational symmetries which could be anticipated and eliminated. Randomness as a concept has become a foundation for many theories. Most famous, perhaps, is the notion that evolution can be accounted for only by accumulated point-by-point random mutations in a gene through, say, heat, chemistry, or radiation. Such mutations are described in one textbook on evolution as undirected. John Maynard Keynes refers to this sort of randomness as objective chance, that is, random and unpredictable to any observer, real or imagined, anywhere, forever and ever. No observer will ever discover the trick or algorithm or alternate theory that could predict when, where, or how such a mutation will arise. Subjective chance, on the other hand, supposes only that the relevant observers on the scene don't know of any trick to explain such events. A pure version of variation in organisms caused solely by undirected mutations leads us to the inevitable conclusion that life itself constitutes a kind of process and distilled universal library whose meaningful strings are located through a winnowing process, that is, by survival within a selecting environment. So how do undirected mutations in a string of, say, 100 codons get processed to form a single competent gene? Between 200 and 300 genes may be necessary for a minimal cellular organism. This collection of genes will rely on other things which aren't inherited, but that's another issue. The random recombinations of just 100 codons would create sufficient numbers of molecules to fill a volume terrifically larger than our cosmos. And the time taken to generate them would likely outlast any number of universes. And yet many organisms utilize thousands upon thousands of genes of even greater length. Evolution as a purely random process seems then to write atop an immense library of Babel. The time frame for the evolution of even the simplest and tiniest living organism, given these additional factors, becomes incalculably enormous. What can give supporters of randomness some comfort, however, is mutation in viruses. Up to 95% of HIV viruses are defective. Most viruses fail, but when they win, they can win big. Such a high rate of mutation allows a scary venture into the unexpected creativity of randomness. But in larger, more complex organisms with far fewer reproductive opportunities, there are a great many corrective mechanisms. Approximately 1 in 3 human pregnancies apparently begin with twin embryos, but the mother's reproductive systems in these cases mostly selects out the fitter of the 2 embryos, and the other is resorbed into the wall of the womb. Such corrective procedures are common in nature even after birth. Mutations that are not already fit to one degree or another are seldom allowed to re-enter the gene pool. These volumes are never returned to the shelves, so to speak. Genes are corrected and repaired on a regular basis, often turning defective or even so-called nonsense genes into competent players. As well, proteins assembled from errant genes are tested, and if found wanting, they are disassembled into reusable amino acids. Deleterious mutations are thus usually weeded out before they ever have an effect on the organism. The genome, it seems, contains its own highly sophisticated and thoroughly cautious editing functions. Random mutations are not always tried in the court of nature. That by itself calls into question the theory of undirected variation. Still, the undirected mutation of genes regarded as heritable traits, has for over a century been considered so logically compelling, so irrefutable, that researchers who sought other explanations were severely criticized by their peers, their mentors, and by most senior scientists. Yet as we explore the apt metaphor of the Library of Babel, the idea behind such objectively random mutation seems both philosophically and mathematically suspect. Meanwhile, the expanding study of epigenetic variation adds to the amazing process of how living organisms adapt to changing environments. If we regard the genome as a piano keyboard, epigenetic variation is like a composer deciding which keys will be played and what melodies will result. It's becoming more and more clear that genuinely random mutation in genes contributes a much smaller percentage of observable variations in wild-type populations of complex organisms. Nevertheless, it is still the academically dominant metaphor, the paradigm. Once remarkably fit and vital, random variation now needs to be edited, judged, and reshelved in the ever-freshening library of observed reality. So that's the kind of stuff we talk about over dinner and in conferences. And it's been a wonderful time doing that, and I want to thank Rick, and congratulations on your birthday. More to come.
All right. Thank you, Greg. Next we have Dan. There he is. Move straight on to this one, Dan.
I put my presentation up.
Is it on the podium PC?
Yeah, it's on the podium PC.
Great. So while Dan's bringing that up, I'll introduce him. So Dan Ling retired from Microsoft 5 years ago as Vice President of Microsoft Research Redmond, although I still run into Dan pretty frequently in our hallways, so he's not completely gone. Dan joined MSR in 1992 as one of the founding members of the new lab. He became director of MSR Redmond in 1995.
So good afternoon, and first of all, I just wanted to say that I'm really honored to be able to participate in this event celebrating Rick's 60th birthday. Congratulations, Rick. All day today, we've been hearing about Rick's very distinguished career, first at CMU, and then later on here at Microsoft Research. But since I've known Rick for, I think, probably longer than anybody else here in this room, I thought we'd go back a few more years and, just for fun, tell you about our times together at Stanford. So I met Rick first when we were both freshmen. Very early our freshman year, we were assigned to the same dorm at Stanford. And it turns out that what drew us together was that we had something in common. And that was that both of us spoke Italian. Not something you might have guessed. Rick was just finishing up a year living in Italy with an Italian family and spending the time studying at an Italian high school. And I was an international student, and I actually was born in Rome and grew up there and went to school there. But I had always gone to an international high school and schools, and Rick had actually gone to an Italian school. So I think at the time his Italian was probably better than mine. during the course of that year, we grew to be very good friends. We were both kind of geeks. Well, we both liked science fiction. And the year was 1970, which was a very eventful year on campus. There was probably not been such an eventful year until maybe last year with the Occupy movement. So you have to remember that 1970 was just after the Kent State killings. The Vietnam War was in full swing. Nixon was president. And campus was filled with protesters. And in the evenings, when we had to cross campus to go to the computer center or to the lab, we had to duck the protesters, the police dressed in full tactical riot gear, and helicopters with searchlights sort of scanning for protesters running around. So it was a very exciting time on campus, and we became very good friends. At the end of freshman year, Rick, another friend of ours, Jeff, and I decided to enter the Stanford housing lottery together. Now, at the time, in order to get campus housing, you had to enter a lottery, and you picked a number between 1 and 10,000. And smaller meant a better number. And if you got a good number, you would get housing. If you got a bad number, you didn't get good housing. And Rick wound up picking for the three of us and picked 9,564. So as a result, we didn't get housing immediately, but we somehow managed to finally get campus housing. And over the course of the next year or so, there were 6 of us that wound up in 3 separate apartments. Now, we were undergraduates, and these apartments were originally built for graduate students, but somehow we got assigned to them. And it turned out that we formed a little dinner club together, and the idea would be that each apartment would cook dinner for a week, and then it would move to the next apartment. So in one apartment, there was me and my roommate Jeff, who's now a dean at UC Davis. And in another apartment was Rick and his roommate Elwood, who went to Stanford Law, became a lawyer, loved the law but hated being a lawyer, and is now a Unitarian minister. And the third apartment had 2 women, Anne, who became Rick's first wife, and Bev, who's now a very distinguished physician in the Seattle area. So every evening, we would cook dinner and have dinner together, and every evening, we would watch one of the reruns of Star Trek. And so I think that, that was probably at least cemented Rick's encyclopedic knowledge of the first Star Trek series. Freshman year was also very interesting. Oh, I have a couple of pictures. So here we are at dinner. Here's me. Here's Rick. Here's another picture with Rick and his roommate Elwood and Anne. And so, and every evening at dinner, I said we would watch Star Trek. Freshman year was also the year that I took my first computer science class. This was CS 106 taught by Zohar Mana on Algol W. Now, you have to remember, again, this was a long time ago, so programming meant you punched cards, ran it on a 360-67, and watched what happened on the line printer. And so this was really a long time ago, but I really enjoyed the programming course. And I would come back and say how exciting this was. And the quarter after that, Rick took his first programming course. So I think in some way I got Rick into computer science. While we were in these 3 apartments having dinner together, we also had a lot of fun. We would have a lot of parties and things. And here are some pictures of some parties. These are a bunch of costume parties we seem to have had. A little Christmas party, and Rick in White Plaza next to the fountain. For those of you who have been on Stanford campus will recognize that. Another little costume party. So we did a lot of fun things together. But I will always remember a particular party that Rick and my friends had staged for me. And this party was based on Mission Impossible. Now, this wasn't Tom Cruise Mission Impossible. This was a long time ago, so it was Peter Graves' Mission Impossible. The one that started out with this recorded mission, and then the recording would blow up, and then he got the dossier, and various things would happen. So they decided to stage this party for me the same way. There was a recording, a dossier, then I got sent on this wild goose chase all around campus, going to various dorms, going to various libraries. I think Rick did some programming, which meant I had to go to different computer centers and load paper tape programs at certain octal addresses to get some codes, all of which wound up being a party, a birthday party for me back at the dorm. So that's a memory that I'll never forget. Another party that my friends gave me was for my 21st birthday. And they decided to have a dinner party, and they invited my parents. So there's Rick and Ann and my parents at the dinner party. And after dinner, instead of taking me to a bar, they decided to take me to a Farrell's ice cream parlor, where in order for me to earn my birthday sundae, I had to get up on the table, have everybody sing to me happy birthday, and that was fine. And this they did to all the other birthday celebrants at the restaurant. Unfortunately, most of the other people were 10 and not 21. So that really brings us to the our senior year and graduation. And Rick did indeed get a degree in English, but he actually majored in mathematics, but he had an honors degree in humanities as well. And for graduation, we had a really nice graduation party, a group of us with our parents, and we had it at a seafood restaurant at Fisherman's Wharf. And I was able to find some very good pictures. There's Rick again, there's me, my mother. This is Jeff's parents back here. This is a picture of Rick's parents at the party. There's me and my roommate Jeff, and I think this is Ann's mother, and that's it. So then Rick graduated, went off to Rochester, and then the rest of his career you've heard earlier today. So I just wanted to thank you again, and to thank Rick especially for being such a good friend and a boss and a colleague and a mentor for 42 years. Thanks so much.
Thanks, Dan. Those pictures are amazing. So, finally, last but not least, we have Terry. So Terry and Rick actually celebrated their 14th wedding anniversary 2 days ago, if I'm not mistaken. I'm trusting Facebook on this one. Terry studied computer science at Carnegie Mellon and the University of Washington before she started at Microsoft in 1997.
Which one works? This one's on but doesn't.
That one works. Yeah.
And can you hook this up here?
Yes. Where's your VGA output?
Probably back here. So I have to preserve the fiction so that I don't get conned into fixing things for my children that I really don't have any idea how to do anything with computers. This works well because this means that when Rick comes home, he has to do all of the computer solving, which he's very good at. My children now believe that there is nothing that he can't fix.
You need to wake your laptop up.
Oh, man. It's a lazy laptop, won't it? Really, it can come out of sleep very quickly, I promise.
If only it were running mock.
All right. There we go. Whatever. All right, so my contribution to the FestSchrift volume was the 7 Habits of a Highly Effective Rick Rashid. I'm not going to focus on a lot of technology things. For those of you that don't know me well, I did work in technology. I was a technical assistant at Microsoft, and my last position was working under Eric Rutter in Bill Gates' office. But I think some of the most valuable lessons that I learned from Rick have to do with how to handle people, how to handle projects, how to handle basically management skills. I haven't necessarily used them in the way he has, but they're good life skills. And I'm not going to cover everything that was in the paper because I do a better job of it there than I would do in person. But loosely, these are 7 habits. I'll give credit to Astrid for the title, but you can see I've got several things on one line for some of these things. People were trying to say that going at the end, other people have already stolen your thunder. But if you read the paper that I've got, the very beginning of the paper talks about how some things are worth repeating. And in fact, in aviation, they repeat all the time that the first rule of aviation is fly the airplane. Okay, this seems a little obvious. It's not clear why you need to teach this, but they do teach it. Because the fact of the matter is, it's very easy to get distracted. Okay, and some of the fatal accidents that occurred in aviation are because the pilot became distracted and they forgot that first rule. So some of the things that I talk about in the paper, in hindsight, or when you talk about them in writing, they seem really obvious, but in practice, they're not done as often as maybe we should do, especially when we're distracted by things. So the first thing that I learned from Rick was give credit, don't take credit. This slide I'm going to use to give credit. Now, you guys all know Rick as being this fantastic technical person, which he is. Since Rick and I have been together, he's also taken on a number of more athletic pursuits. And the first couple of those pictures are his first backpacking hike in the Cascades. Now, being the problem solver that he is, Rick, after this hiking adventure, which he was very dubious about, decided that the Cascades were a fine place to go. But they really needed 2 fundamental engineering things, which was escalators and bug zappers. He thought if we had those things, that hiking would be a wonderful experience. I also do running and dog events. Rick, I don't know how many of you know this, has done a 50-mile ride on horseback. The last couple of pictures are from the bottom 2 are from his first 50-mile ride. And then I have to give him credit, that top right picture is taken on Father's Day. So I'm the one that does horseback riding, but he still went out with us on Father's Day. The application of this kind of give credit, don't take credit thing in management really comes down to everybody wants to be recognized for their work. That's normal. We put in a lot of hard work on something, and we want people to know that. But the problem is when people are working really hard to take credit for things, sometimes other members, in their group or in the organization feel like that credit's being taken from them. And something I learned from Rick is it's much more effective to give credit. Recognize the people around you for what they've done. Recognize people in other groups. I've seen Rick do this in meetings all the time in the company. He won't just recognize groups in his organization. He'll recognize groups in other organizations that have contributed to that work, and he builds great relationships by doing that. Okay, this is where repetition works great. I don't know how many people I've heard today talk about how optimistic and positive and fun and humorous Rick is. It's a fundamental quality of his. You might wonder why these pictures are here. I had, and I talk about this a little bit, I had a situation right after we moved to Arizona where my top horse that I was hoping to get onto the U.S. endurance team became injured. And I was pretty upset by this, but I've had the benefit of having known Rick for 2 decades. I've been married to him for 14 years. And over that time, he has taught me to, when something bad happens, this is how he handles setbacks. He looks for the next opportunity. He doesn't stay focused on what went wrong. He simply moves on to the next thing. And so at that time, we decided to go and work on learning to fly, because I didn't have a horse to ride at that time. And I also went back and focused on my running a little more and managed at Portland to run my fastest marathon in 10 years. And those were both fun things to do. But the flying was particularly special because it gave us both a completely new hobby to work on together. And previously I would have been all depressed and upset about the horse being hurt, and I would have been really focused on that. We didn't. I remember looking at the vet saying, fine, give her the time off, you know. And he looked at me, he goes, nobody does that. Everybody asks me about what aggressive therapy can I do on my horse to get it ready to go again, even though the vet will tell you the best thing is rest. And I said, no, it's fine, I'll do something else. Well, that worked out really well, because just recently, and some of you guys know this from Rick talking about this, that same horse, after having her rest, came back and she won what was for us was a test event, a 65-mile ride. She got best condition. We beat the nearest competitor by 38 minutes. She set the fastest time on that course in 10 years. And she and I will be going to Texas at the end of the month to try for the US team. And if it doesn't happen, I will look for the next opportunity. I'm skipping over some of the things because obviously I will not have enough time to touch on everything in the paper. These are fun. There's actually two of the things on my list from the paper could be covered with these pictures. These are pictures of our sons visiting CMU in 2009. We had a great trip there. And the boys got to go around and look at the research projects just like Rick and I were doing. At various times they were separated from us. The one where the top two pictures where they're working with some of the robotic stuff, they were with somebody else at that time. And the thing I wanted to bring up about CMU here is one of the things that I learned both at CMU and from Rick is the idea of the reasonable person principle. And again, people have touched on that today. It's take an environment where instead of constraining people by a bunch of rules and trying to carve out this little hole where they have to do things a certain way, where they can only have a certain number of resources. Instead, take the principle that we're going to expect people to be reasonable. Okay? We're going to expect people to make decisions that are correct for the work they're doing while also considering the other people around them and the needs of the organization. Okay? And Rick does that fully in Microsoft Research, and you've heard a lot of people talk about the freedom that they have with Rick as their manager and the trust. And some people talk kind of nervously about the level of hands-off that there is. But I get to see this from the other side because of that trust and that freedom and that not micromanaging everybody. This organization scales, okay? You take these people, and this gets to another one of my points, which is mentor and delegate. You hire really great people, you mentor them into their roles in whatever areas they may need help at, then you delegate. You expect them to be reasonable. And then you can let them work fairly autonomously in order to get great research done. And I get to see at home, he has a huge organization. There are problems that come up. And yet when he's with the kids and I, he's with us and he's not worrying too much about what's going on with the project. Some of this gets to things I'm not going to talk about right now, the discipline, decisions, and time management, which is just to say that he's really good, that if he decides he's going to do something, he's going to do it now. If he wants to convince somebody that some particular coding idea will work, he does. He'll go bang out some code, and then like Galen said, and Rich alluded to, he will only write the minimum amount of code necessary to prove the point. Which of course means that when Rich goes and rewrites his code in the kernel, because he doesn't want his code there, he's just made Rick's point, which is he won. He convinced somebody, yes, you guys really can do this, and then they'll go and do it the right way. The boys are kind of fun. You can't even tell if they're playing their games or looking up. Yes, they're looking up, sort of. Something that they have gotten from Rick, and I'm glad they're learning it at a young age because I still struggle with this, is this discipline to get things done at a particular time. Kylan told me the other day when he was getting his homework done right after school, which is typical for them. He says, well, it's like Dad says, I don't want to have to worry about this later. I'm just going to get it done now. And that's a very handy skill. So the don't worry. Okay. Yeah. I don't quite manage this one yet. Yeah, actually, in this particular shot, I'm not really worrying. It's just my instructor has asked me to calculate some distance to a detour and stuff like this. So I'm trying to both fly the airplane, which I've been told I should continue to do, and do some calculation. This is a candid shot, and I saw this. I thought it would be funny to put up for this slide. I can't tell you how many times I've heard Rick say, well, I'm not worried. there are times, especially as a mom, when this can be a little frustrating if he's saying it in response to me expressing some worry of my own. But the fact of the matter is, he's right. Worrying, in my mind, is when you sit there and you keep thinking over and over again about a particular problem you have. You may even be considering some different solutions for that problem, but you're not making progress. You're simply rehashing the same stuff over and over, and you're stuck in indecision. And I've seen this happen, at work as well. Rick doesn't do this. He doesn't worry. Astrid was nice enough to help me look over the paper in advance, and one of her comments alongside of the paper had nothing to do with my many grammatical errors. This particular comment, when I said, he says, "I'm not worried." Astrid said, "Yes, I've heard him say this." And I know a lot of you have as well. But it's who he is. He doesn't worry about things. He will consider information, he will make a decision, and then he'll move on. If he delegates something to somebody, he's going to delegate it. He may mentally decide he's going to check back with them at some point. But then he moves on to the next thing, which for me is great, because if we're at home and we're doing a vacation and he has to, deal with a particular item, he will deal with it, he'll move on, and then we'll be, still enjoying our family time. Don't worry, be happy. Again, getting back to the fundamental optimism. Rick has made me a happier person for many, many reasons. So I've heard so many people stand up here and say, "Rick, thank you for my career." And certainly he has had an impact on my computer science career as well. But I get to stand up here and say thank you for my life. Not only have I learned a lot of things that I have applied, because I've been active in other organizations as well, about how to be optimistic, how to not worry, how to take steps and move on and be happy and have fun with what I'm doing. But these very qualities that make him such a wonderful manager pay huge dividends in life. And I am still learning from him every day how to deal with whatever tasks I'm doing, whether that might be something, with the horses, or it might be something with people. To keep a positive focus, to not get really pulled down by complicated details. I think probably a lot of you that manage people know even harder than technology issues are people issues. If you're dealing with topics that are very sensitive and polarized, where people have been struggling with a disagreement for years, and I've had to do that actually not too long ago in one of the equestrian groups I was dealing with. It's really hard. People get very passionate about the things that they believe in, and that passion is great. You want that. You don't want people to be apathetic, and we have a lot of that kind of passion in research. You want people to be very passionate about what they do, but then you have to tread very carefully to try to, and something Rick does here that I think is amazing, is he will redirect people to a common thing that they do believe in. So maybe you're talking about people at Microsoft. Well, most of those people really do want the company to do well. They want the products to be great. And sometimes you have to find that common goal and then try to talk about it from there. And he's really good at this. So, Rick, I love you very much. I thank you for everything you have taught me and everything you continue to teach me. And I also wanted to say thank you to Rich Draves for pulling this together. I know those of you that have been involved with the presentations know just how much time Rich has spent on this. And Jamie also has spent a lot of time, and Peter for his help getting things started. And I think we should have Rick get up here now, because it's all about him, and he should come say some things. What do you think? Which I guess means I should give him my microphone.
Unless you want to respond.
So I really appreciate this opportunity for rebuttal. I mean, a number of kind things have been said today, and I really appreciate that. But the truth is that if I have a talent, I think it's been in having a knack to associate myself with friends, with students, with colleagues and employees that are incredibly smart, really good at what they do, genuinely nice people, and incredibly generous. So thank you very much. This has been a wonderful day. Thank you.
All right, thank you, Rick. So we're almost done. I just want to say a couple more things. I want to thank a few people who were involved in helping organize this FestSchrift. First, I want to thank Peter Lee because he first suggested the idea of a FestSchrift when most of the rest of us hadn't even heard of him. And also, I want to thank Peter for working with me on the organization. He had some great advice. I want to thank all the speakers, all the people who flew here from out of town to participate. When you're trying to put on an event like this, you never know what you're going to get, and, and I think you've seen everyone came through amazingly. So actually, I want to give all the speakers one more round of applause. I want to thank some of the people who really helped with the nuts and bolts of putting this on. We had the idea of doing videos for Nathan and Avi very late, really only about a week ago. And then when we actually got the footage, there was this task of editing. And Henry Honig and Daniel Betcher from the MSR Media Group jumped in and spent it's incredible how many hours it takes to just edit like a 20-minute video. You have no idea if you haven't tried to do it yourself. So Henry and Daniel did an amazing job on the videos. You saw the results. Let's thank them. And then we had some great administrative support, and I think you saw that if you were on the mailing list. So Jamie Riffley, Jennifer Carlson, Melissa Kelly, Pamela Ash, we just hired recently to get involved with editing the book, but you'll be dealing a lot more with Pamela going forward on the book, but she also pitched in and started to help put on our event here, for example, working on the agendas. So let's thank all of those people. So with that, I think we're done here tonight. Some of us are going to be going on to a dinner, and there'll be vans for you outside. So thank you all again. Mm-hmm.